Imagine you have a recipe. The ingredients in the recipe will be enough to make a certain amount of, say, the cakes. If you have twice as many ingredients, then you can make twice as many cakes. Now, by the same thinking, if you want to make half as many cakes, you only need half as many ingredients. Now, in that example, there is a clear link between the two quantities, the number of cakes and the amount of ingredients that you need. And a change to one causes the same numerical change to the other. If you double one, then you double the other. If you times one by 10, then you times the other by 10. And if you divide one, for example, by, say, 3, then you will also end up dividing the other one by 3. Now imagine that you are painting a room. You will take a certain amount of time to paint the room. Now, if you find someone to help you, you double the number of people that are painting the room. But it will take you half the time. You'll be painting twice as quickly, but it will take you half the time to do it. If you find a third person to help you paint the room, then you will have 3 times as many people, which means you can do it 3 times faster. It will take you 3 times less time. And again, there is a clear link between the two quantities in that example. The number of painters and the time taken to paint the room are clearly linked. But this time, while there is still a change to one causing a change to the other by the same numerical amount, the changes happen in the opposite direction. As one doubles, the other halves. As one times is by 3, the other divides by 3. So the changes are the same numerically, the same factor, but in opposite directions. And we need to be able to work with this idea. This idea of two quantities that are linked, but will either change in the same direction at the same time or in opposite directions at the same time. With any of these questions, we need to know 2 things. We need to know how much the quantities are changing by what numerical factor, and we need to know whether they're changing together or whether they're changing in opposite directions. So they are the 2 questions that we ask ourselves whenever we've got one of these questions. With any of these questions, we need to know 2 things. We need to know how much the quantities are changing by what numerical factor, and we need to know whether they're changing together or whether they're changing in opposite directions. So they are the 2 questions that we ask ourselves whenever we've got one of these questions. Let's have a look at an example. There are 500 sheets of paper in a pack. 500 sheets of paper weigh 2.5 kilograms. Work out the weight of 50 sheets of paper. First thing we're going to do, step 1 in any of these questions, is we're going to draw ourselves a very quick table. We're going to have 2 columns. One column is going to be one of the quantities, the other column is going to be the other quantity. So we're going to have sheets of paper and weight for our 2 columns. And we're first of all going to fill in the information that we're given in the question. 500 sheets of paper weigh 2.5 kilograms. We then run through those 2 things that we need to know. First thing we need to do, we want to ask ourselves, are they changing together? Well, we want 50 sheets of paper. If you have less sheets of paper, what will happen to the weight? If you have less sheets of paper, they will weigh less. So they must be changing together. They are both going to change by the same amount, and they are both going to change by in the same direction. Decrease one, we decrease the other. How much is it changing by? Well, we can look at the sheets of paper. To get from 500 down to 50, we have divided by 10. If they are changing together, the weight will also divide by 10. And if we do 2.5 divided by 10, we are going to end up with 0.25 kilograms. So 50 sheets of paper will weigh 0.25 kilograms. It takes 2 painters 4 days to complete a job. How many days would it take one painter to complete the job? So step 1, we're going to set up our table. Our 2 quantities, head of our 2 columns, number of painters, and time. It takes 2 painters 4 days to complete the job. We ask ourselves a simple question. If we change the number of painters, and we change the number of painters to 1, are the 2 quantities going to change together, or are they going to change in opposite directions? Well, if we have fewer painters, then it's going to take more time. Less painters, more time, which means they change opposite to each other. There is no real way to work out whether they're going to change together or opposite other than by just thinking it through. Think logically with it. There's no trick questions here. It's going to be together if it's going to be together in real life. It's going to be opposite if it's going to be opposite in real life. I'm going to start with the number of painters. We've divided the number of painters by 2. Half as many painters. Now if we've got half as many painters and they are changing in opposite directions, then while the painters divides by 2, the time will times by 2. It will double. Same numerical factor, 2 in each case, but one halves and the other one doubles. So while 2 painters takes 4 days, 1 painter is going to take 8 days. It takes 5 machines 6 hours to make 1,000 DVDs. Work out how long it would take 4 machines to make 1,000 DVDs. So we need our 2 columns. Notice that there's an extra number in here that doesn't actually matter, because our 2 quantities, our 2 different ideas going on, the number of machines and the time. It's 1,000 DVDs in both cases, that doesn't change. The only things that change are the number of machines and the time that it takes for the machines to make 1,000 DVDs. It takes 5 machines 6 hours to make 1,000 DVDs. And we need to work out how long it would take 4 machines to make 1,000 DVDs. We ask ourselves a simple question. Are they going to be changing together or are they going to be changing separately? Well, if we decrease the number of machines, if there are fewer machines making DVDs, then it is going to take longer. So as one goes down, the other is going to go up, which means they are changing opposites to each other. Now the problem here is that we start with 5 and we're changing down to 4. There is no easy way to go directly from 5 to 4. So why don't we go via a middle value? Why don't we scale down to 1 machine and then scale back up to 4? With 5 down to 1, we'd have 5 times fewer machines. We'd be dividing the number of machines by 5. And if they're changing in opposite directions, if we have 5 times fewer machines, it will take 5 times longer for them to do it. 5 machines take 6 hours, 1 machine will take 5 times longer at 30 hours. Okay, well that's halfway there. Because now we don't have 1 machine, we have 4 times more machines than that. We have 4 machines, which means it will take 4 times less time to make the 1,000 DVDs. 30 hours, divide that by 4, 7.5 hours. Exactly the same setup, we just had to go via a middle value because it wasn't so easy to get from one to the other.